evening to all. Can all of you hear me? Good evening to all. Can all of you hear me? Okay. Yes, fine. Okay. Shall I switch off the video? Yes. Okay, fine. What about now? Is my voice clear? Okay. So today we are going to start the module 4. The module 4. So in that we are going to discuss about the first topic is the principle of location. Okay, location. So that is not the location of it is not meant the geographical location. It is meant for locating the surface of the workpiece for machining operation. Got it? Locating the surface of the workpiece for machining operation. You got it? So, for what purpose we locate the workpiece while machining? For what purpose we locate the workpiece for machining? Any idea? Why we locate workpiece during machining process? If you didn't perform that work properly, what will happen? Yeah, the dimension accuracy will be poor. Am I right? So that is the first thing. The dimension accuracy will be poor. Yes. Then anything more? What about the surface finish? What about the surface finish? Is it fair? If you didn't locate the workpiece in a good way, yeah, it will be poor. So that is another problem. Okay, the surface finish. Yes. Next is, anything more? What about the motion? What about the motion? The movement of the workpiece? Yes, that is how many degrees of freedom will be there for the workpiece? How many degrees of freedom will be there for? How many degrees of freedom will be there for the workpiece in area? Is my voice clear to all? Is my voice clear to all? Yes. 1 minute. Yeah, fine. How many? Come back to my question. That is, question is here. How many motions are there for the workpiece? What are the various degrees of freedom for the workpiece? Yeah, if I take a rectangular workpiece, how many degrees of freedom will be there? Yes. Yeah, X, Y, Z, linear motion will be there. Say this is my x-axis and this is my y-axis and z-axis is there. Linear motion is there. How many linear motions? Yes, that is the plus and minus linear motion is there, right? That is here it is minus y. Here it is minus. Here it is plus z. So here it is minus z. And here it is minus x. Like that. Totally, how many linear motions? 6 linear motions are there. Agreed? And then, how many rotary motions are there? For all these axes, there exist motions, right? Rotary motions. Along the x-axis, clockwise as well as anti-clockwise motion is there. Isn't it? So like that, how many? 6 rotary motions are also there. Agreed? So total of how much? 12 DOF we have to arrest. But by means of location, you have to arrest what? You have to arrest all these motions, right? You have to arrest all these motions. That is next thing. The rotary as well as linear motions we have to arrest. That is next thing. Is it clear to all? Next is, see, can I use, listen carefully, can I use the same locator for different shaped workpieces? Can I use the same locators for no? So, what shall be the condition while manufacturing the locators? It should not be fixed one, isn't it? It should not be fixed one, isn't it? That means it should not be, one term is what is called as, it should not be redundant. In your theory of machines you learn that, redundant. That means it should not be fixed. It should not be redundant. That means it should be flexible. According to the varying dimensions of the workpiece, it should vary. Got it? Is it clear to all? Up to this clear to all? Yes. Next is, to locate these points, you have to use only minimum number of locators. That is the next condition. Minimum number of locators. Minimum number of locators. By means of minimum number of locators, you have to lock all these motions. And then the last condition is the locating surfaces must be perpendicular. Perpendicular. See, if I want to locate or if I want to arrest the motion along minus y-axis, yeah, it should be perpendicular to the minus y plane. That means this plane. Got it? Is it clear? If I want to arrest the motion along x-axis, it should be perpendicular to this plane. Like that way, it has to go on. Okay, so these are the conditions why we locate the workpiece during a machining operation. Up to this clear to all? Yes, fine. Okay. Now, let's come to the degrees of freedom. How many degrees of freedom? According to our condition? Please help me. How many degrees of freedom according to our condition? Yes, 12 degrees of freedom. What are they? 6 linear, right? The 6 linear and the 6 rotary. Am I right? The 6 linear and 6 rotary are there. Agreed? Yes, fine. Next is, I am going to lock all these things by means of locators. For that, one principle is there. That principle is called as 3, 2, 1 principle. 3, 2, 1 principle. That means 3 locators, 2 locators and 1 locator. Let's see what it is. So to arrest these 12 degrees of freedom, we are using which principle? 3, 2, 1 principle. Let's see how it is. Yes, fine. So I am going to draw one plane. Which represents x, y, z axis, and in that A workpiece is also kept. So this is one plane. Another plane is here. And the bottom plane is also here. Like this. And the workpiece is also drawn. This red color is the workpiece. How many degrees of freedom is there? 12 degrees of freedom is there. I am going to locate it by means of 3, 2, 1 principle. Okay, fine. So the first 3 locators are kept at the bottom. I am going to mark it as blue. 1, 2, and 3. By means of these 3 locators, 1, 2, 3 locators, which degrees of freedom get arrested? Before that, let me mark the axis first. Say, this represents, 1 minute, this is our x-axis, and this is minus x. This is positive y, this is negative y, this is positive z, this is negative z. Okay. X, y, z, minus z, minus y, minus x. Please check your audio system. I hope my voice is clear to all, right? Is my voice clear? Yes, right. Okay. Let me change my net connection. Net. Please wait. What about now? What about now? Is it clear? Yes, fine. Yes, okay. So let's come back. Here you can see that I marked all the axes. X, y, minus z, minus y, z there. Okay. So I drawn here 1, 2, 3 locators there. I marked here 1, 2, 3 locators. Have you seen that? In blue color I have marked there. Okay. My question is, which degrees of freedom will be arrested by means of that 1, 2, 3? By means of this 1, 2, 3 locators, which degrees of freedom will get arrested? X, Y. Think and answer. X, Y, which rotation? Sorry, which motion? X, Y, can it rotate like this? No. Can it rotate like this? No, it can't. Right? What about the y-axis? Can it rotate like this clockwise or anti-clockwise? No, it can't. Got it? So, 2 rotary motions along the x-axis, 2 rotary motions along y-axis. Which linear motion? Which linear motion is arrested by 1, 2, 3? Yes, the z minus z motion is also arrested. Isn't it? Can it move downward? By means of these 3 locators, can it move downward? No. By means of these 3 locators, that motion is also arrested. Got it? Okay, fine. So by means of 3 locators at bottom, How many degrees of freedoms are arrested? 5 degrees of freedoms are arrested. Agreed? Which are they? Yes, the clockwise and the anti-clockwise motion along x and y, and then the linear motion along minus z. Up to this clear? Okay. So, what is our principle? 3, 2, 1 principle. Out of that, 3 is over. Next is 2. Yes. Now, we are going to give that 2 in this plane. Let me change the color. See, in this plane, I am going to give the 2 locators. Okay. Please tell me, which degrees of freedom will get arrested by means of that 2 locators there? Yes, Google, you can move it along z-axis. Positive z-axis is free now. Will it be located by means of this bottom one? No. It is free to move along the top one, isn't it? It is free to move upward. It will not be arrested. Only the minus z will be arrested. Is it clear, Google? Okay. Then, by means of this violet color, this portion, by means of these 2 locators, which degrees of freedom will get arrested? That is my next question. Can the z-axis rotate along clockwise and anti-clockwise direction? No. It will be arrested by means of these 2 locators, isn't it? By means of these 2 locators, that will get arrested, isn't it? It will not rotate. Yeah. Next is, what about the linear motion? Can it move along the minus y? Can it move along the minus y? No, it will not. Okay. So, by means of 2 locators, where at a plane, how I am going to define that plane? At a plane perpendicular to the first plane. Can I say? 2 locator at a plane perpendicular to the first plane. That is this one. Got it? 2 locator at a plane perpendicular to the first plane. This is the first plane. This is the second plane. How I define that second plane? 2 locators are placed in a plane which is perpendicular to the first plane. Okay? And then that will arrest how many degrees of freedom? How many degrees of freedom? 3 degrees of freedom are arrested. 3 degrees of freedom are arrested. Which are they? How many rotary motions? 2 rotary motions are arrested. Which are they? Z-axis. Isn't it? Z-axis. Yes. Clockwise and anti-clockwise rotations are arrested. And next is, how many linear motions? 1 linear motion. Yes. Minus y-axis is arrested. Up to this clear? Yes, fine. Next is, then last one is the one more locator is also there. That is what? 1 locator, right? 1 locator. Okay. That will be kept over this plane. Here like this. That is the third plane. How I define the plane? That plane is perpendicular to the first and second planes. Can I say? Yes, the third plane is perpendicular to first and second plane. So, the third, the one locator is placed in a plane, perpendicular to both the planes, right? Both the planes. And then, by means of that, which degrees of freedom will get arrested? Only 1 degree of freedom will get arrested. Am I right? Yes. Which is that? Minus x linear motion is arrested. Minus x linear motion is arrested. Up to this clear one? So, totally, how many degrees of freedom are arrested by means of 3-2-1 principle? 5, yes, plus 9 degrees of freedom are arrested. Agreed? Yes. So, how many remaining are there? 3 degrees of freedom are remaining. Which are they? Yes. Now also it is free to move along. Positive x, positive y, and positive z. It is free. Agreed? Now also it is free to move along x, y, z direction. That should be locked by means of proper clamping system. Proper clamping system. Okay? So 9 degrees of freedom can be arrested by means of 3-2-1 principle. Agreed? 3-2-1 principle. And the remaining 3 degrees of freedom will be arrested by means of what? A clamping system. Up to this clear? Okay, fine. Let's see the note. Hope all of you can see the note. Can all of you see the note? Okay. So here it is written there, the basic principles of location that I already told you. These are the 6 principles here. That is a dimension. Next one is accurate machining surfaces. Next is it should prevent the linear and rotary motion. Then redundant locators means what? What is the meaning of redundant? Fixed locators must be avoided. Okay. And then what about next one? The locating points must be minimum. Then locating surfaces should be perpendicular. Okay. Then how many degrees of freedom? Totally 6 degrees of freedom. Total degrees of freedom are there. 6 linear motions and 6 rotary motions. That is the figure it is shown there. Okay. Next is the 3-2-1 principle. Yeah. You can see the figure here. The 3 locators are kept at the bottom there. Okay. And by means of that 3 locators, it is given there. Arrest minus z, arrest clockwise and anti-clockwise motion of x and y axis. Total 5 degrees of freedom are arrested. Okay. And next is by means of 2 locators. Yes, it arrests minus y and rotary motion along the z axis. Total of 8 DOF are arrested. And next is 1 locator. That is arrest minus x linear motion. Okay. Up to this clear to all? Yes, fine. Now we can move to how we can locate it from plane. Okay. Locate from plane. That is plane surface. That is what we are discussing right now. That is by means of 3-2-1 principle, we can locate with the help of a plane. But the next case is somewhat different. Locating from a circular surface. Locating from a circular surface. That is next thing. There exist 2 ways are there to locate it from a circular surface. The one is by means of concentric circles. And other is by means of conical surfaces. Okay. Again, this conical surface is classified into 2. By means of a hole. That is one thing. And another one is by means of the circular surface. By means of a circular surface. These are the 2 cases. Okay. So locating a workpiece which is having circular surfaces. That is task. We can locate it by means of a concentric circle principle. And the second one is by means of conical surface principle. Conical surface principle is again classified. One is hole and the second one is by means of circular surfaces. Okay. Next is how I am going to locate it by means of a hole there. Okay. For that, I took a circular shaft. A circular shaft is taken. And here, to locate this between the two machining ends, you have to put a small hole here. Here you have to produce a small hole like this. And into that small hole, how we are going to locate it? Yes, with the help of conical shaped, locators. Okay, this cone up to this portion will be entered into this hole like this, and it will get arrested. Got it? The best example of just such a type of locators is you have seen in lathe machine. In first year you have seen the lathe. Is my voice clear to all? Is my voice clear to all? Yes. Vaishnav, I think it is problem from your side. Please check your net connection and audio connection. Okay. And next is, so here the two, it will be kept like this. The workpiece is here like this, and it will be located with the help of V locators like this. Sorry, conical locators like this. Here you can see that by means of a hole it is located. Then another thing is there. That is, a workpiece is here like this. I want to machine a circular surface. It is a circular surface. I want to machine the top surface. This surface has to be machined. That means it will be like this. This is the workpiece. Okay. I want to machine the top surface. So if I place a hole over here, can I machine the top surface? If I put a hole over here and I am going to insert this conical locators into that, means can I perform the machining operation here? No, it cannot be. So thing is like this. This end will be made in the form of cone like this, and that will be inserted into a cup which is having a cone shaped structure. That will get locked off. Got it? These are the two methods how we are going to lock it by means of what? A conical surface. That is here, conical surface. By means of a hole and by means of a circular surface. Here you can see that. See, the circular surface is locked here. The circumference is locked here by means of what? The cup-shaped structure. Clear? Up to this clear one? One more method is also there to lock this one. That is by means of V locators. Sorry, that is also written over here. By means of V locators. V locators. Okay. So how you might have seen in workshop the V block. Have you noticed the V block? An item like this. Hope all of you have noticed in workshops, right? Yes. You can easily place the circular surfaces by means of this V block, right? That is, the circular surface can be easily placed over here like this. And it will get locked off. That is also an example of what? Locking it by means of circular surfaces. Here also you can see that the circumference of that item is locked. You get it? Okay. Is it clear to all? Yes, fine. Now, we are moving to next one. That is by means of concentric circles. By means of concentric circles. Have you seen the drill machine, the hand drill machine? You might have seen that machine with the electricians, plumbers, etc. Okay. Have you noticed how that drill bit is fixed there in the machine? Yes, by means of a chuck. By means of a chuck, you are right. How it works? That is, it is based on the principle of concentric circles. Concentric circles. It consists of jaws, right? It consists of jaws like this, and the workpiece will be kept here like this. How the motion? All these jaws moves in such a way that it is passing through certain concentric circles, right? That is, the radius from here to here, here to here, here to here will be same. That is what we call as concentric circle method. So, the circular surfaces can be fixed or located by means of what? A concentric circle method. Is it clear to all? Okay, fine. Now let's go to the note. Locating from plane. I told you that the reference flat surface of the machine tool, it is by using 3 to 1 principle. Okay. Next is locating from circular surfaces. Yeah. They locate the base and axis of the work. That is the first thing. So hence it can rotate about its own axis. How we can fix the base and axis of the workpiece? That is by means of conical locations and by means of delocators. One more item is also there. Which part is that? By means of concentric circle method. Okay. So in the case of conical, you can see that it can be by means of a hole and by means of a circular surfaces inverted to form the cup. Okay, you can see the figure there. Here it is locked by means of what? Can all of you see this? I shall zoom it. Now is it visible? Yes. You can see that. You can see that there exists a cone there. Here also it is also a cone. Okay. Here you can see that the workpiece is kept over here like this and it is formed a cup here like this. It is enclosed inside a cup. Okay. So here no need of putting hole or the surface of the workpiece. Okay. Next is the V locators. You can see here. By means of V block, it is going to lock. The angle, included angle, is found at 90 degree. That is written over here. Okay. Next is concentric loading. Yeah. That you already told. Chuck is a common example. Up to this clear? Okay, fine. Now, I told you that the remaining 3 degrees of freedom out of 9 will be locked by means of what? 9 degrees of freedom are locked by means of locators. Remaining 3 will be locked by means of, yes, clamping system. So that is the next thing we are going to discuss, clamping. So, what are the requirements of clamping? The first requirement, already you know, the degrees of freedom should be arrested. That means the motions should be arrested. That is the first thing. Am I right? And next one, anything more? What are the requirements? Or we can say, what are the principles of clamping? Why we go for clamping? The first one is this one. The motions can be arrested. The second one, anything? If I want to machine this surface, yes, by means of clamp, I can hold this surface in a correct position. Am I right? Akshay, please refresh your page. Refresh your page. You can click on the refresh button. Okay. Okay. So that is the first thing. The position. The position of the workpiece. The position of the workpiece can be arrested. Yes, Rohit, what are you saying? Yeah. Next is the strength of the clamp. Strength of the clamp. What is the thing? What is the meaning of that? The strength. I am going to machine. Listen carefully. I am going to machine a lathe bed. You might have seen the lathe bed. Okay. I am going to clamp it by means of a screw. Is it clamp it properly by means of the screw? A small screw? No. Isn't it? So the clamp should be in such a way that it should arrest the workpiece properly. That means it should overcome the cutting forces. It should overcome the cutting forces. That is the thing. Got it? It should overcome the cutting forces. That is the case, the strength of the workpiece. Up to this clear to all? Next is, if there exist lot of clamps are there to machine a workpiece. Listen carefully. If there exist a lot of clamping units are there to lock a workpiece, what is the problem? If there exist first clamp here, second clamp here, third clamp here, fourth clamp here, fifth clamp here, all these are tightened by means of a nut and bolt by using spanners. What shall be the problem? It consumes, yes, right. It consumes more time, right? So the productivity will come down. So the next term is the productivity. How I can increase the productivity? Yes, the time taken should be minimized. The time taken should be minimized. That is third one. Next is, if it is like this, by using the nut and bolt, is it easy to the operator? No, it is very difficult. Each time he has to take the spanner and dismantle it and dismantle it, isn't it? He is wasting time as well as it is difficult to the operator also. So, which method you can use? Yeah, you can use the magnetic chuck, isn't it? Or you can use some other hydraulic or pneumatic systems to lock this, isn't it? So, by means of those systems, we can lock all these things. Right? So, that is next thing. Is to the operator. Is to operator. And next is clamping design. Clamping design. Yes. If you make a clamp to hold only rectangular workpieces means, is it fair? No. It should be in such a way that it could hold multi-dimensional workpiece. Like that way you have to design the work clamp. Otherwise, it will be a great loss to that entrepreneur. Okay. Up to this clear to all, what are the requirements of clamping? Let's see once again. What are the requirements? The first one is which one? Yes. Position, right? Position. That means the accurate position you have to place, isn't it? The strong area or high strength area of the workpiece we have to keep. Next one is which one? Strength of the clamp. For what purpose the clamp should have enough strength to withstand what? To withstand cutting forces. Right? To withstand the cutting forces. Yes, right. And next is, what is next thing? I give the term productivity. For what purpose? Can you say how I can increase the productivity? By reducing the time, isn't it? How? By reducing the time of clamping, right? By reducing the time of clamping, we can increase the productivity. Next is, yes. What about the next one? is to the operator. Yes, very easy. You have to, dismantle it and mandle it, isn't it? Next, last one is what? Clamping design. Clamping design. Yes, it should be in such a way that it should clamp more than one type of workpieces. Okay. Is it clear to all? Okay, let's see the note. Requirements of clamping. See here, the position of the clamping. It should position the strong pieces, and then, see, the clamp should not obstruct the path of cutting. It should not obstruct the loading and unloading of workpiece. See, like that way you have to position the clamp. Next is strength of the clamp. It should hold the workpiece firmly against the cutting forces. So one more thing is also there. It should not damage the workpiece. Don't make any impressions on the surface of the workpiece by means of this clamp. That is next thing. Okay. Next is productivity. The time can be minimized. Which can be if the clamps can be tightened and loosened quickly. Next is to the operator. Yes. By means of hydraulic or pneumatic system, we can make it easy. Okay. And next one is what? The clamping system. It should be in such a way that it should accommodate different dimensioned workpieces. Okay. So these are the clamping principles. Up to this clear one? Yes, fine. Now, we are going to discuss about the types of clamps. Types of clamps. Okay. The first type of clamp is what we call as strap or bridge clamp. Strap or bridge clamp. Okay. So here it is very simple in construction. That means there exists the workpiece is here and placed on a surface, and here there exists one strap. This is the strap, or we call this as the bridge, and there exists one protection for this strap to touch the surface of the workpiece like this. That portion is called as heel. Heel. This is the workpiece. And what is this thing? This is called as strap. Okay. And here there exists one head pin is there. Head pin. That is a pin which is fixed to the ground. Okay. We call this as head pin. Okay. This is the surface of the workpiece, machine tool. And then how it is locked over here? By means of nut and bolt. Spring loaded nut and bolt. Okay. So here okay. The spring is also there like this. So based on the dimension or size of the workpiece, this will be moved up and down and it will get locked off. And only this much portion will touch the surface of the workpiece. Why? If this much portion is the entire portion is touched on the surface of the workpiece, that will make certain impressions on the surface of the workpiece. To avoid that, only this much portion is in contact. Okay. And that contact point is what we call as a heel. This is a single type of clamp. We call that as what? Strap clamp or bridge clamp. Clear one? Okay. Next is another type of a strap or bridge clamp. Yes, is called as swing clamp. Here, in the above case, you can see that it seems to be very much difficult for unloading and loading of the workpiece. Okay, if it is a heavier one means it is very difficult to take upward or slide towards this direction like that. If this strap clamp is rotated about this axis and this can be moved in this direction means, yeah, that will be much more easier. That is possible with the help of the swing clamp. Okay. So in the case of a swinging clamp, it will be like this. Here is the workpiece. Okay. And in their clamping system is like this. It will be in such a way that, okay. And here, this is a head pin is here. By means of this one, it can rotate. And by means of here, it is locked by means of nut and bolt. Okay. And it is arrested by means of a stud over here, which is also locked by means of a nut and bolt, here like this. And that is, you can see that no difference is there when compared to the bridge clamp. What difference is there? The difference is mainly for this strap. This is the strap. If you check the top view of the strap, it will be like this. On one side, there will be a hole. And on the other side, there will be a slot like this. There will be a slot like this. So what is the benefit? By means of this slot, it can be inserted, right? And it can be locked by means of this nut. By slight releasing of this nut, very easily you can swing by using this head nut. Yeah, clear one? So here, it can rotate about which axis? About a vertical axis, it can be rotated like this. But then also some problem is there. What is the problem? Yeah. If it is a heavier workspace means you have to lift it upward, right? Since it is rotating along a horizontal axis, yeah, it makes some obstructions for that movement of the workspace upward. That also one problem. Notice. To overcome that problem, again, the swing clamp is modified. Up to this clear point, the swing clamp, the strap clamp, and the swing clamp explained. Okay. And the next one is, okay, hinged clamp. By means of this hinged clamp, you can rotate that strap unit along an axis, that is, along a horizontal axis. It can be rotated. That is a benefit. That is like this. Let me draw. You have to notice how I am going to, how I am drawing, so that it will be easy for you to draw at the time of examination. Okay. here there exists a hinge. Here also there exists a hinge. Okay. And it is here there exists a stud which hold one nut and bolt. Sorry. Which hold a nut and bolt. Okay. And next is a strap is there. Similar to that, similar to the previous cases, here also one strap is there. That is kept over here like this. And this strap is locked over here by means of a nut and bolt. Okay. The workpiece is kept in between these two items and it is locked by means of a stud, which is also locked by means of a nut and bolt. Sorry, a nut, a hexagonal nut. Okay. So here, this is the workpiece. Here is the strap. Here is the hinge. And here, this is what we call as hinged bolts. Hinged bolt. Okay. So what will happen while dismantling? Yes. That is happening like this. Let me draw once again. Please refresh your page, Saidu. So here, while dismantling, this will go like this. This stud will go like this. Okay. And here, it can be more rotated like this. See, that strap will be here like this. So that very easily you can remove the workpiece from over here. Clear point? Got it. So these are the two stages. And you have to explain for your examination by drawing these two figures. Okay. So we discussed the three types of clamps right now. That is a strap clamp, then next is a swing clamp, and next is hinged clamps. Up to this clear to all? Next, have you noticed the milling machine or drilling machine? And here, on those cases, we are measuring the top surfaces. So by means of these type of clamps, so far we learned, by means of these clamps, so far we learned, can I measure the top surfaces? Can I measure the top surfaces? No, we can't, isn't it? In the first case, here also, we can't measure the top surfaces. In the second case also, we can't measure the top surfaces. In the last case also, we can't measure the top surfaces. Okay. So to measure the top surfaces, we have to use the clamp called as side clamp. Side clamp. Okay. Let's see how it is. That is very simple. And in some cases, it will be complicated also to hold certain workpieces. That is, right now I am going to draw a complicated figure. Here it is the case, like this. Okay. Is my voice clear to all? Okay. Fine. And okay. Here is another thing, and it is kept like here also like this. Okay. So this is the figure, and workpiece is kept over here like this. This is the workpiece. and the clamp is going to be placed. Sure, sure. Sure, Anand. Yes, you can see that. Like this, you meant like this, right? This is the clamp. And next is the nut is there. Hexagonal nut. In this case also hexagonal nut is also here. The stud is inserted into the body of the holding device like this, and it is loaded by means of spring for easy removal. This is the stud, and here also the hexagonal nut is there. And it is also spring loaded also. It is loaded by means of spring. You can see that this is one type of clamp. Very easily you can machine this surfaces without any problem. Okay. This is what we call as a side clamp. Is it clear to all? This is the side clamp. And the remaining all these things are what? The holding devices. Okay. So these are the four types of mechanical clamps. Which are they? The strapped clamp, then helping, the strapped clamp, swing clamp, right? The swing clamp. The next one is hinge clamp, and the last one is side clamp. Okay. Then you have to learn two power clamps also. Lot number of clamps are there. Out of that we are learning only two. Two power clamps are also there. Okay. That is by means of magnetic force and by means of vacuum. We call that as vacuum clamping. And another one is magnetic clamping. Up to this clear to all? Okay. Let's see the note. Here you can see the strap clamp. Here you can see that this is the bridge or strap, and here is the heel. Yes. And then what piece is kept over here? Hexagonal nut for tightening. You can see the spring also for loading, for easy removal. Okay. Next is the swing clamp. You can see the clamps there. It is having a slot-like shape. See, different shaped clamps are there. Here, all these things can be easily removed without complete loosening of that nut. Okay. Next is hinge clamps. You can see that the two figures are drawn over here. Okay. Here it is called as the hinged bolt, and here is the hinged strap clamp. Okay. And next one is the side clamp. Okay. This is one kind of side clamp. You can see that the two sides. Yes. Don't worry. I will forward it. I will upload the video also. Okay. The video of this class also. So here is the side clamp. Here you can see that very easily you can machine the top surfaces. Okay. And here another strap clamp, that is what I drawn here. You can see that the stud is completely dropped into here, and here there is a spring over there. Okay. And next I told you that two power clamps are also there, which are the vacuum clamp and magnetic clamp. Okay. So let's see. By using this figure itself I shall explain. You can see here there exists, this is the bench. over which there exist lot of ducts are there. You can see that small ducts are there. And these ducts are connected to a vacuum pump like this. These ducts are connected to vacuum pump. The maximum depth of this duct is how much? 0.25 millimeter depth. When it is connected to this vacuum pump, what happens to the material which is placed on the surface of this duct? Will be pushed down. Am I right? Will be pulled inside, right? Oh, is my voice clear to all? Yes, fine. Okay, it will be pulled downward. And for what kind of, that may be because of net connection, Vignesh. Okay, poor net connection. It consumes only very small amount of data. It consumes only nearly 50 MB when you are in the class. Okay, but you require good connection. On the top of the screen, you can see the symbol of that your net connection. Please check that whether it is green, red, or yellow. If it is green means it will be good. If it is yellow or like that means okay. That means sometimes it will be fluctuating. Sometimes you will get the good color. Okay. If it is green means you can sit inside the class. Yeah, red means it is poor connection. Okay. Now I have green here. So I think that may be your side. Okay, fine. So here, by means of vacuum pump, it is evacuated. So what happens to the material which is placed on the top will be pulled in, isn't it? So you can't fix heavier workpieces. You can't fix only sheets. Especially the sheet metals which is used for making cars can be clamped by using which one? By means of vacuum clamping. Clear? Is this vacuum clamping clear to us? There exist small ducts are there. The duct is having a height of how much? 0.25 mm. And these ducts are connected to glass also. These ducts are connected to what? Vacuum pumps. These ducts are connected to vacuum pumps. Okay. And then it is useful only for holding thin sheets. Yeah, glass can also be connected. Okay. You might have seen in certain automotive industries video, the windscreen of the glass is held by means of what? Yeah, vacuum cups, right? Just like that. Okay, vacuum clamping. And next is another type. The last one is what? The magnetic clamping, isn't it? Here you can see that. You can see that there exists a table. The table have, this is a table. The table have alternate arrangement of non-magnetic materials. See, this is one non-magnetic material, another non-magnetic material. Like that, non-magnetic materials are kept alternately over there. And then below that, you can see the permanent magnets. You can see the permanent magnets here. What will happen? Listen carefully. What will happen when this permanent magnet is here? It is a non-magnetic material. Will the surface be magnetized? No. What will happen when it is kept over here like this? Yeah, the surface will be magnetized. That means it will hold the magnetic material, that is magnetic work material. The workpiece is if the workpiece is a magnetic item, magnetic conductive item, that will be held by means of what? This permanent magnet. When I move this lever like this, what will happen? You can see that all these permanent magnets are broken by means of what? This non-magnetic material. What happens to the workpiece? It is released. It is unclamped. Am I right? Please listen once again. You can see that this is the permanent magnets. 1, 2, 3 permanent magnets are there. That is kept on a magnetic surface. These are the magnetic surfaces. 1, 2, 3 are the magnetic surfaces. and you can see that the workpiece is kept over here. Because of that magnetic surfaces, it gets blocked off. Now in the second case, I move this clamp to this direction. You can see the second figure. What about the conditions here? These are non-magnetic materials. Now the permanent magnet is in contact with the non-magnetic materials. What happens to the surface? This is a non-magnet. So that what happens to the workpiece? Yes, it gets unclamped. So this is how the magnetic clamps work. Clear one? Yeah, free to remove. So we completed fourth module. Is it clear to all? Okay. So I will send you a set of questions. So your next class will be on, I will send the date through your WhatsApp. Okay. The next date. Most probably on coming Wednesday or Thursday. Okay. Don't know Google. So far, I think that it will open according to the information which I got. If anything there means, I will inform you. Okay. I hope it is clear to all. So I think we can stop for today. Yes, fine. Okay. Is this class okay to all? Yeah, okay. Okay then. Bye all.